So we'll get started here. So today's speaker is a really good friend of mine, Dr. Darren Haver. He's so good, such a good friend, I have to read what his description here. He's got a bachelor's degree in ornamental horticulture from Cal Poly Pomona. He has a PhD from UC Riverside in botany plant sciences. His background's horticulture, but his title, he's a farm advisor in, horticulture advisor in Orange County and Riverside?
Just Orange County.
Orange County for water resources and water quality. And he and I have been working on runoff projects for 8 or so years. So, and he also, just this year, he became the director. The University of California has a system of research and extension centers throughout the state. Darren's the new director of the Research and Extension Center in Irvine. He's going to talk to us today about conserving water and, yeah, I can never remember the title of his talk. But he's going to talk a little bit about the research that he's conducted on landscapes, features that conserve water, features that actually mitigate pollution, and then I'll leave it at that for you.
All right, great. Thank you, Lauren. Feel free at any time to ask me questions. I'll just keep track of the clock and hopefully not take you guys too long into the next period. I guess I need to be watching for what, 1 o'clock is the max time, or before that? Probably won't be that long.
You have to be out of here.
Don't fret. Okay. So I know that you had several lectures throughout the series, maybe some of them you haven't been to, but I think the concept of the first part of the series was to kind of look at the impacts of urbanization on, on land use, on our natural resources, particularly, water quality and water resources. I looked through some of the presentations that were given, and I saw you had a presentation on fish and the impacts of urbanization on how fish are able to spawn and all those type of things. And there was a little bit in there about things you could do in the urban landscape to take care of those issues or mitigate those issues. I'm going to go into a little bit more detail, hopefully not give you any duplicative stuff, but you might have heard a smidgen of a little bit of it. So this is a picture that I always kind of start off with. It just shows you a nice forest, and I always ask the question, when you see a forest like this, do you think, how good is this forest at taking care of or mitigating any kind of pollution that may fall? Let's say you've got a lot of atmospheric deposition of nitrogen. What does this system have that maybe an urban system doesn't have? Anybody? How about like a healthy soil with a lot of organic matter? Contrast that with what you find outside here right now, probably in most cases, it's just paved over asphalt, concrete. Okay, you're not going to get a lot of filtration into the soil. You're not going to get a lot of biological activity that's actually going to be able to filter pollutants that you're putting out into the environment. So that's not your typical, in most places in California, this is kind of your typical landscape in a lot of the areas that I'm from. Along the coast area, you have your coast live oak areas, and down in our area we have the open space areas that are all your manzanitas and your ceanothus and those kind of environments. But same type of thing. I mean, this is a much healthier system than some of the systems that we've created in our urban environments. And when you have these kind of things and you go from this kind of an area and you shift to this, what's going to happen to surface runoff and the ability of the landscape to filter? It's going to be decreased significantly. And in many cases, surface runoff will increase, and I think you've probably heard all kinds of numbers, but you hear anywhere from 50 to 70% increase in surface runoff when you go to a system like this. Okay, and when you do that, there's going to be detrimental impacts to that. If you're any applications of any fertilizers, any applications of any pesticides, or any other chemicals, they don't have the option to really settle down and break down and move into the soil and filter. Most likely they're going to end up on a hardscape surface, and they're going to move off into and concentrate into local creeks or streams or a lake or whatever is in that particular system. Where I'm in Orange County, everything where I work drains into the Newport Back Bay. And that Newport Back Bay is a protected estuary, federal estuary, and they've spent millions and millions and millions of dollars dredging that bay of sediment, dredging that bay, and it has toxicity issues from pesticides, it has nutrient issues because it has algae blooms. All those issues have to be paid for by us collectively. So what we're trying to do is start to design landscapes that can mitigate that a little bit better and be more synergistic with the native environment. So here's just we're going to go through some of the characteristics of urban landscapes, and I try to throw in some photos here of things that I see when I'm driving around that kind of catch my eye, and I think, oh, that's a pretty bad design there. There's some that I still haven't got some real good photos of, but I'll talk about them in just generalities. So here's something you see quite often. It's not maybe quite as common up here in this particular area, but in Southern California, there's this belief that you need to, and speaking from, I'm not a landscape architect, and you'll see that as we go along here, but when you look at landscapes, there's this belief in Southern California that you want to basically, when you go to a shopping center, or when you go in front of a gauge or some kind of an urban area, they tend to cover things, so you don't necessarily see the tops of the cars. Your eye kind of goes up. So, and they do that a lot with these big sloping turf grass areas. And so here's an example of out in front of a homeowners association. The entrance is here. And they're kind of covering that wrought iron gate that's maybe not that attractive, and you don't really see that until you get up closer. So from the road, you're just going by and you see green turf. The problem with that is that you have these large areas of turf grass. They're sloped pretty significantly. It's actually kind of entertaining to watch people mow and maintain these kind of things, because they're basically pushing a lawnmower up here or running after as it goes down into the street. And then there's a sidewalk that's put in place, and then you have the street right here. So when you do applications of fertilizers, or you're trying to put irrigation water on, anything that on top of that that was applied, so any pesticides or any fertilizers, run very, very quickly off of this soil profile onto the sidewalk and out to the street, into the storm drains, and then we have that negative impacts on our local creeks and streams. So common thing, turf grass is a big thing. Most people, when they move into a new home especially, they've got maybe 60 days, sometimes it might be 6 months. They need to put in their landscape, and they need to do something quick. So most people go down and call the sod farm, and they say, okay, just deliver a big pallet of sod, and I'll put the turf grass in front. Or a developer may do that for them. And for the most part, it's going to look something little like this. You know, it's not a big landscape in front of the house. This is the very common, obviously there's exceptions to that. You can have larger estates, but for the most part, this is what our landscape is becoming dotted with. So you have the lawn, and you have the sidewalk, and the gutter, and then you also see right here, there's a little hole. Do we know what that is?
Drainage.
Drainage from the front and backyard, so that's a curb core. So anywhere there's drainage around this structure, it's going to go into a drain, and it's going to end up very quickly out to the street. Okay, so we'll talk a little bit more about that in a little bit. So streets, driveways, sidewalks, all the hardscapes, for the most part, are generally impervious. And they're also directly connected to each other. So a pathway in the back will lead to a sidewalk that runs to the front that leads to the driveway, which leads to the sidewalk on the front and then out to the gutter. So when you have that kind of system and you have anything falling on that, if they're sloped to get rid of the runoff, it actually runs on out to the street and again carries all the pollutants with it. This is an example of an HOA that has no sidewalk or no curb. They have a sidewalk, but they have no curb and gutter system. It's just a flat area. And they have a little bit of a swale here. And I don't think I have a photo of it this time, but they did put in a management practice or a BMP to catch some of that water. So they have a nice swale that kind of catches the water as it runs down the street. But as you can see, what's happened here is that it's not really all that effective. You can see on the asphalt that the way the runoff just basically, and what this runoff is actually from is the sprinklers that are irrigating the swale. So the developer put in what they were supposed to do. So they put in a swale, but then they kind of lost track and they actually said, okay, well, we need to make it look good, so we're going to put in the most common turf grass, which is tall fescue, marathons. They put that in, and then now they're maintaining it like it was a typical turf grass area. So it's really losing its ability to do what it originally was planned to do, which was catch runoff and filter pollutants. So now it's kind of contributing to the problem. So they're fertilizing it, they're mowing it, all those things, and they're having to irrigate it. It doesn't really solve the problem that we're talking about. Okay, most of our plant materials that we use are those that require a lot of nutrients to maintain their green color, as well as usually require a lot of water, although what we're finding is there are some plants out there that we think use a lot of water, but maybe don't necessarily need it much as we're giving it. But for the most part, that's the belief that most people have is regular water, regular fertilizer, especially for turf grass. So here's our typical landscapes in Southern California. Landscape drains. Landscape drains, obviously you've got to move water from the landscape as well as keep it away from the house. But one of the issues you have with these kind of landscape drains is, especially in older homes, this is a park situation, but you do see this in homes sometimes too, where they've got a drain right in the middle of the turf grass. And again, that's plumbed directly into the curb core that we showed up at the street. So anytime you do any applications of any kinds of chemicals, especially fertilizer, people don't cover those things, they don't even think about it. They just basically go right over the top of it. So you're basically putting pollutants directly into your storm drain system that way. And then in older homes, people kind of lose track of these. You could be out gardening and doing something in the yard or doing some kind of other activity, you'll be digging, and all of a sudden you'll hit something and you'll, I didn't even know there was a drainage pipe there, or some kind of other drainage system. So that's an issue. This is probably the #1 issue, and I think it's one of the reasons why we hand out those keys that you got earlier for the sprinklers, but that's just one of the ways that we get information out to the general public to let them know that one of the biggest issues that we deal with is just poor irrigation. Poor design of the irrigation, poor maintenance of that irrigation, and then also poor scheduling. People just, it's kind of this thing that people don't understand. They just like to turn on the water. As long as everything's green and looks good, then things must be irrigated properly. And that is true in that case, but you know, we've got plenty of runoff issues, or runoff during the rain, or we got sprinklers that are turned the wrong direction and not even watering the landscape, they're watering the hardscape. Pressure too high in your system, you know, you get this misting effect, and that causes runoff very quickly, and you also don't get real good distribution uniformity onto the actual plant material that you're probably trying to irrigate. So this is a real common thing where people have installed a new irrigation system, didn't check the pressure that was coming into the system, and then they end up with these sprinklers that are basically misting like you're in Palm Springs at a restaurant somewhere. The other issue that we often kind of don't think about, and generally it's kind of an ag issue, is the movement of sediment. Generally the thinking is once you urbanize and you start paving over everything and you do put landscapes in, you're not going to have a lot of sediment movement. And I'll show you how that, we found that not to be the case, but this is just an example in a landscape where there's actually a broken sprinkler. And that sprinkler hasn't been fixed for some time. So it's picking up sediment, mulch, and everything, and moving it across a hardscape system. It's hard to tell, but this is sloped right out to the street into a gutter system. And so again, it's a way to carry pollutants. And one of the biggest pollutants that we see on sediment are all the new pesticides that are out there. All the new pesticides that we generally use absorb to organic matter very, very well. And the idea is that they absorb well so that they stay on site. And that's true as long as this doesn't happen. Okay, and what we're finding is this happens more often than not, and we're ending up with pesticides in the streams and the creeks again. Often you'll see broken sprinklers. You know, that's just poor maintenance. Okay, and that's very, very common with, you know, I'm talking homeowners as well as commercial, but even homeowners even more. Most people, if you know, they don't see any brown spots or any of that kind of thing, and their irrigation comes on at 4 or 5 o'clock in the morning, they're not interested. Then there's these kind of designs. And these are becoming more popular again. They were popular a long time ago, and then they kind of disappeared, and now we're seeing them pop up in some of the new developments. This is down in Corona del Mar, so this is about, I don't know, maybe 2 blocks from the beach. This is a little bit further up, but what's difficult about this? It looks good. How do you irrigate that? You know, unless you're going to do you've designed some sub-irrigation way that you can irrigate that and not have any runoff, you're going to have several sprinklers throughout, and you're going to end up watering a lot of hardscape. And you're going to have a lot of runoff. It's just going to happen. And often that's not thought about. I mean, this turfgrass, again, is a high water user. You put a real fine strip of turfgrass and you surround it with a hardscape that gets real hot, you're going to have to irrigate that a lot. Question?
What type of grass or ground cover would you suggest using instead? Because I know that's a really nice, like, popular design now.
It is a popular design, and to be honest with you, my suggestion is it's just not a good way to go. Plant material in a situation like that is almost impossible to irrigate properly. And then also you have other issues that I see. Usually it looks good for a while, but then once it's been driven on and you park cars near it, or it's hard for homeowners. I get a lot of calls from homeowners. I've got this design, and I've got brown spots or yellow spots, and it's like, well, you're parking your car anywhere, you get all the fluids coming out. It just doesn't look good. So if it's going to be an area where it doesn't get high traffic, you might be able to get away with it and use some kind of stuff.
I mean, what about like a patio or something?
You might be able to get away with it in that situation.
Because even
absolutely.
if it was like drought tolerant or some sort of like a succulent.
Yeah, so you could use succulents, the thymes, those kind of things. Those would probably work better in that kind of situation. Absolutely. Yeah, and we do see that used more for pathways, walkways, that kind of thing, and that's probably a good use of that.
I mean, I imagine if there was like a grass that was like would infiltrate the water. Do you think there's a way you could design it to make it actually beneficial?
You probably could. You probably could. I think it's probably. I think probably the big challenge I could see. I actually could see using sub-irrigation in this instance, especially if it's a little bit wider strip. What do they call these Hollywood? Pasadena driveways. So you could probably get away with doing something with sub-irrigation in that. The choice of turfgrass, I think, is going to be key. A lot of people still are using the tall fescue, which doesn't recover real well if it's damaged. So you're probably going to have to go something that has a little bit more aggressive root system, rhizomes, stolons, that kind of thing, or the warm season turfgrass. And then you're fighting the whole dormancy thing and all that kind of stuff. So I don't know if there's an ideal plant or situation where you can get it done, but it's probably possible. But you have to keep that in mind. I mean, the other thing you'll do is you could see that you could mitigate your runoff here somewhere, and I'll show you how that could be done. You know, you could have the design up there, and then you need to make sure that you've done some other mitigation to take care of it. Here's a picture of that little bit of a swale. You can see the turfgrass going right down into the swale. It doesn't become a real effective swale though, because if you're going ahead and fertilizing it and watering it, it's basically just part of your lawn. So here's an example of that curb core. This photo was actually taken out in the Corona Temecula area in Southern California. You can actually kind of see the green cast in the gutter here, which means you're growing algae, right? What does algae need to grow? It needs nitrogen, but it also needs water there all the time.
Right.
So that means there's water in these gutters all the time. It doesn't dry out. Okay, so whether that's from irrigation, it could be from car washing, it could be from any of the other activities that you may do in and around your home, this is just a constant thing you see, and that's why we kind of have that term urban drool. It's just kind of a constant thing that's going on. Okay, and so the project that Lauren and I are working on, I think he talked a little bit about it at the first class. That project is looking a lot at just how much urban drool is going on. We see it all the time. We can go out any time of day to any of our sites, and there's always some water to catch. Now, you'd think that wouldn't be because everybody's always grown up with these signs. I know I have. No dumping drains to ocean, or they talk about whatever rivers close by to wherever you live. Don't dump, and this includes go right into the storm drain. And this has been somewhat effective, but I think there's still when you go out and talk to people, they understand that yes, okay, it drains to the ocean, but they often think of dumping. Like it says dumping, so they think of the person that is dumping a can of oil or doing some kind of activity, washing their paint can out in front of their house. They're not really thinking about the day-to-day activities that they do around their home or what's going on in their landscape that also contribute to this, because that adds up over time. And that's what we found in our research, that if this is going on 24 hours a day, 7 days a week, maybe it's a very tiny amount of nitrogen that's in it or pesticide. But if you add up all those days over the entire year period, you're going to end up with a large, large load of whatever it is, nitrogen or a certain type of pesticide. So people don't really have that connection yet. They still don't quite understand that every activity they do around their home could have an impact downstream. Okay, so obviously these things go into these storm drains, and for the most part, in Northern and Southern California, once it gets out of your developed area, it goes into some kind of a natural stream. There's very few cases, maybe in obviously Los Angeles and some of the older developed areas, they go into nice big concrete flood control channels. They've gotten rid of all the natural vegetation. So it's a little bit different system, and it goes right out to the ocean. But most of the newer developments, it's basically into a stream or a creek that is not used for flood control in that sense. Okay, so you get all those pollutants, trash and sediment, all those things. In the dry weather, they end up on this apron, and then once you have a big storm, it pushes that out into the creek further on or into the ocean. And in Southern California, we're always having beach closures because of that. Right before or after a storm, that's when they have the beach closures. But a lot of that stuff's being loaded up into the system all the rest of the year, and then when we do get that first big storm, that's when it gets pushed in, closes the beach. So you end up with all kinds of detrimental effects. So you got algae blooms. This is a picture of the Newport Back Bay, and there's all kinds of floating algae mats. And for the most part, one of the things we also have a hard time with is convincing people that yes, what you do around your home has a negative impact downstream, but should you care about that negative impact? Some people don't have a connection with the environment downstream. Maybe you can't always use, well, do you go to the beach and go swimming? Well, some people never go to the beach, especially in certain areas of Southern California, further inland. It's just not something they do on a regular basis. They're not surfers or whatever. So you got to find what kind of beneficial use that they think they have for water, and that could be simply that it's used for drinking water if it is, if it's some kind of other recreational activity like fishing or all the things that you've heard about. People usually have some connection in that sense. Okay, so this is just kind of summary of the things that our current urban landscapes result in as far as water quality. And so we said increase in impervious surface. That's 50 to 70% increase in surface runoff when you do that, urbanization. Okay, the rainfall is not contained. So in those first couple slides that I showed you, when you have a rainfall event, most of that water is going to end up percolating into the ground. It's not going to be true in an urban area because that's not what we want it to do. We want it to move away very quickly from all of our structures and then funnel it off to a lake or a stream or creek over the ocean. The other thing is that we disturb and we compact and we pave over all the soils. So even if you have a good soil system or had one there, when the development is put in, it's basically removed. So you're going into sometimes a very sterile environment that doesn't have the capacity to filter nutrients and break down pesticides. So you end up with poor infiltration and percolation, and then when you have a rain event or you try to irrigate, you have runoff very quickly and very easily. And then lastly, you see really an increased use of fertilizers and pesticides to maintain the aesthetic value of those landscapes. People want things to look a certain way. Obviously, there's some homeowners that have more tolerance than others, and it really depends on the situation. But for the most part, we are using more fertilizers and more pesticides in that situation. So what I want to do now is I want to go through a demonstration, outreach, and also research project that we put together at the South Coast Research and Extension Center in Irvine to kind of look at some of these things. About 5 to 6 years ago, we had a lot of pressure, a lot of people asking questions from stormwater viewpoint, working for the counties, working for the cities, working for professional landscape contractors. They're all coming to us and saying, you know, we don't really know what to do. What kind of things should we start implementing? What works? What doesn't work? What isn't extremely costly? Because there's a lot of nice things you can do if you've got a lot of money to spend. And it's getting even worse now. I mean, people aren't willing to come in and just rip out a landscape and put in all these great features that mitigate pollution. Okay? So developers also came to us and said, you know, what works, what doesn't? We've got all kinds of companies coming to us saying that they have the magic bullet, this will solve every problem that we have. What do we do? So we came up with this idea of putting together a few landscapes that took some of these ideas that weren't real expensive, and we tried to plug them into a residential landscape and see how well they work. And so the designs were, we had one typical landscape. So we wanted kind of our control, which was our conventional landscape that was very simple, was very similar to those pictures that I showed you at the beginning where there's turfgrass in the front. And basically I call this my Home Depot Lowe's yard. So all the plant material is stuff you could walk into one of those big box stores and you could find really easy. The irrigation system, similar to that. All the features are basically conventional or traditional. And then we took that same landscape and we said, okay, what are 2 other options that people could do? So if they've got that regular landscape and they're looking to make some changes, what kind of things could they implement? So we call those 2 landscapes, the 2 different types of low impact landscapes. So what I'm going to do is I'm going to take kind of a little virtual tour of what these landscapes ended up looking like and some of the results of what we did find. I should say that the landscapes, again, I told you earlier, I'm not a landscape architect. What I ended up doing is I ended up interviewing several landscape architects that were working at the time when the economy was good and houses were being built like crazy in Orange County. I went out and I found 3 or 4 of them and I interviewed them and I said, you know, if I was a client and I was coming to you and I gave you this list of things, what would you design? And I needed it to be something that was pretty basic that the typical person would want to maintain. I didn't want anything elaborate that a gardener would want to do. It's the homeowner that goes to work, comes home, opens their garage, and doesn't really look at the landscape. That just has to look good for them on the weekends. Okay? So the first landscape is the traditional. So again, high percentage of impervious surfaces. So it has the driveway, it has the concrete walkways up next to the structure. Okay, we had solid pipe drainage, so there's drains throughout the landscape. They're all connected to solid drain pipe, 4-inch drain pipe that comes all the way to the front of the landscape into a curb core out to the street. Okay. We had large cool season turf areas in the front and the back, so marathon tube. Then we had poor irrigation design and scheduling and maintenance and installation, because I did the installation, and I'm not an irrigation installer, but I wanted it to have, you know, heads that were higher than others and mismatch things. And basically, like if I went down to the hardware store because some sprinkler broke, I just find the one that fits, that, you know, you can basically tinker toy kind of thing, put it together. That's what that landscape irrigation would look like. And then we put a mixture of high and medium water demanding plants. Many of them are believed to be high in water. There are actually several in there that we found don't really need as much water as we thought they did. So that's that traditional landscape. So it ends up, we have a footprint of we don't have a full-size house. The grant that I wrote this for, you know, they wouldn't find me building 3 full-size homes. But I had a structure there because I also wanted to look at what happens when what falls on the roof. So you got deposition of nitrogen that falls on the roof. You also have deposition of any volatile pesticides that are used, can land on the roof and run off. And I wanted to find out what happened when we had a rain event. What was in that water? And is that a source of contaminant out to the street? So this has got, you know, European white birch out front, 2 or 3 of those. It's got buxus, it's got star jasmine, it's got hibiscus, it's got magnolia, and it's got a whole lot of turf. Okay? So that's basically the design there. There's a quick picture of the backyard. And then we did all kinds of things wrong, like put in trees that were excessively root bound in the middle of the lawn, and then irrigated on default every day. So the clock was set, worst case scenario, which is, you know, most people will set the clock once and then never change it again, and they let it come on, you know, every day no matter what. You know, impatiens and tosperum and agapanthus, you know, all your typicals that you would find. Patio out back, concrete patio, okay. And you'll see later on how that became kind of important there. Landscape drains dotted throughout. We had some queen palms there too as well. So I think you would agree as architects that these are probably the plant palette that you see the most common, especially if a developer were to come in and say, okay, we want to do all these homes, here's the list of plants that you'd probably be able to choose from. As well as also from availability. Okay, so then we did that for about 2 years. We ran that system, and we were able to determine how much we had pulse meters on the water meter, so we were able to determine how much water we were putting on that landscape. And then we were also able to collect all the runoff from each of the landscapes and say how much surface runoff was coming off those. Okay, and I'll show you the data that today. So we did that for 2 years, worst case scenario, and then once we were done with this particular grant, we decided, okay, most people have that landscape, and most people don't have the money right now to go in and make all the changes that we want them to make. But are there things that they could do in their existing landscape that could improve things? And so we kind of came up with a list of things, and then we've been training a lot of the homeowners associations on these various things. So, you know, just getting in there and fixing, doing some maintenance on the irrigation heads makes a big impact on it. Adjust the spray patterns, as we were showing earlier, where we were all tweaked, maybe not spraying in the right location, reduce the pressure so you don't have misting. Mulch, big one, you know, mulch the entire landscape. And then schedule irrigation we started using watering index. So most of the new clocks have this little setting right here called water budget %. Okay? And the way you do this is you set the clock, you determine how much your longest run time is going to be, which is going to be July, August, the hottest time of the year. So let's say at that time of the year you need to irrigate your lawn for 15 minutes to get enough water on it. Okay? You set that time in the clock, and then you never go back to that time and change it. You don't do that anymore. You basically go to that little dial, watering budget, and you say, okay, this time of the year, it should be using about 50% less. And there's websites you can go to and get the information on what the watering index is for that particular day or week, however often you want to change it. And you just change it to 50%, and it reduces all the run times 50%. Okay? So that's a quick way of doing it, because people don't like to change things on their clock. They get very confused when you start changing minutes, days to irrigate and all that kind of stuff. So this was just a method to do it. And we also have a wireless unit that you can actually purchase and put inside your house, so you don't go out to the garage or anything. It just sticks on the refrigerator wherever, and you can turn it there. So those are available too. So that works pretty good. But there are days when, you know, if it's extremely hot and the watering index is using historical information, you could have a problem if you don't make those adjustments. You might not irrigate it. Okay, the second landscape. This one, the main goal here was just to make everything as pervious as we possibly could. Okay, the soil that we were working on was a very sandy loam soil, so we had good infiltration, good percolation, so we didn't have to worry about those things. So these would not be good BMPs for a lot of places if you have like shallow groundwater or you have soil that does not infiltrate well. You'd have to come up with alternative practices. So we used pervious patio and walkway. So it was flagstone, but instead of sinking it in concrete, which is what most people do, we put it in decomposed granite that had a small amount of a binder in it to bind the decomposed granite together, even more than it normally does. You can use all kinds of binders. Some of the binders, if you use really high concentration, it ends up not being pervious at all. It's just like concrete. We used a Mediterranean plant palette. So again, I didn't tell the architect what plants to use. I just said pick those that we know are good ones to use for a Mediterranean plant palette. Instead of having solid drainage pipe for all the landscape drains, you can use perforated pipe. And that's a pretty common thing now. You put a sock over the top of it, and then the sediment won't go into the pipe. And almost like a French drain type system. And then we switched from the cool season turfgrass to warm season turfgrass. The irrigation system was designed by a professional, and I can't stress this even more, that this is an art that we really need to focus on. You know, properly hydrozoning the landscapes, as well as working hand in hand with that designer before you have your design done. Because I see a lot where the design is done and they hand it off to the irrigation person, and I've talked to a lot of those consultants, and they're like, we do our best to try to match products that can actually do what we want them to do for that particular thing, but we usually have to put sometimes more sprinklers than we want to, or we know we're going to have overspray. We can get the plants covered, but we know we're going to have overspray on the hardscape because of that. So work very closely with them. Make sure you're designing hand in hand. The irrigation is not controlled. It's got a controller in it, but then we also installed soil moisture sensors throughout the landscape. So instead of relying on historical information on how hot it is or just the temperature, it actually is measuring the soil moisture. And it tells the controller whether to allow an irrigation to occur or not. Okay, so basically what it does is it'll water the same amount of time no matter what, but it changes the frequency. So instead of watering every day, it may say that it needs it maybe every third day or every fourth day. And you don't have to make that decision again. The irrigation clock does that. We also collect rooftop, we had rain barrels installed. And rain barrels don't really cost out when you talk to water districts. They tell you that it's too expensive. The water's cheap enough that you don't really have a good benefit in that. But it's not for me just water conservation purposes. It's also for water quality, because on those low storm events, you can collect a lot of that water and keep it on site, and then you can use it again, and rather than letting it run off, okay, and carrying all the pollutants. We installed a driveway slot drain, and then also a gravel pit. So I'll go real quick through that design. So this is that same one right next to it, but we have the new design. All this equipment here is monitoring equipment, in case you're wondering why the lawn has all this stuff sticking out of it. But these are just soil moisture sensors and other devices that we're measuring. This is your typical driveway interceptor. This one is one I took a picture of down in Crone Del Mar again. Not cheap to install or purchase. They're usually pretty fancy looking. So we wanted something a little bit more cost effective. So what we put in was a slot drain. So you basically put these pipes in, these 4-inch drain pipes. They put the driveway, install the driveway over the top of it, they put a little pattern of flagstone in there. Once that's all done, you come through with a saw, concrete saw, and you cut through that a slot right through that joint and basically cut a little slot right in that drain. Okay? So then what happens is the water falls off the roof onto the driveway. It starts running down the driveway, but it'll fall into that slot, and then it is pitched to a vegetation on either side. So either the turfgrass or a planter or whatever. And so studies have shown that the most runoff from a storm event are going to come from the roof onto the driveway and then out to the street. So if you can mitigate that, you can keep a lot of things from moving off site. So there's the slot after it's been cut. And it's not real noticeable, which is also nice. You know, you really kind of have to walk up onto it to see it. Okay?
The water goes down the driveway?
The water's going down the driveway. This is the facing the street this way.
Huh?
Okay, so the water's coming down here and it falls into there instead of keep going down out to this apron on the driveway now. We've got several of those on there. We don't just have one here. I don't know if I have a, there's just up close. There's the back. Some of the drawbacks to using the DG, you still get it breaking off, and so homeowners don't like, you know, dirt and stuff that's on their patios and things. They like that clean look, which is why a lot of people still hose off their hardscape surfaces, and I'll talk real quick about that. This is us installing the drainage pipe, and this is our gravel pit that it's not very aesthetically pleasing, but we wanted to mark it so we could show people. You could design this so it looks a lot nicer, but basically all that landscape drainage, as well as the slot drains that I showed you, all drain to a gravel pit. So there's about 7 feet worth of gravel, so it's like a dry well. And I think Julie last week talked about a dry well. I think she might have showed a couple pictures of it. This is similar to that, but you basically fill that hole with a lot of gravel and you line the outside edge of it with weed cloth or weed geotextile of some type so you keep the sediment from coming in. But it just basically is a holding basin for under low storm events or irrigation or whatever it could run off the property to allow it to seep back into the soil. If you have a big storm event, there's an overflow on the side here that takes it on out to the street, so you don't have flooding issues. Okay, here's the system that irrigates. We have 8 different soil moisture zones. We connects right to your existing controller. This is the add-on feature here, so there's 8 zones. And what you have is just a dial that says wet, dry. So if you think your turf is too dry, you dial it a number down, make it wetter. And it'll just allow it to come on more often. Instead of every 3rd day, it'll now come on every other day. That's the only kind of changes you need to make. And after you've basically established the landscape and done that, you don't really need to change it anymore. It basically adjusts for that. The biggest thing is you got to make sure you put that sensor in the root zone of whatever plant you're going to use as your indicator. If you put it too low or too high, you're going to be under or over watering. And there's other sensors that are available that we test as well to see how they do. Turf grass in the front is Seashore Paspalum, which is a warm season turf grass that withstands a lot of salt. So it's used on golf courses a lot, but homeowners tend to like it now as well. You can mow it really short like Bermuda grass or let it get 2.5 inches tall and it gets kind of spongy. A little bit patchy, but people tend to like it. So there's the sensors out in the middle. There's what the sensor looks like. They're buried in the soil. In the parking strip, we put UC Verde buffalo grass. So that's one that's bred by the University of California. There it is in the back. It only has stolons, so it's not quite as aggressive. It doesn't have any rhizomes that go in. We took all the sprinklers, we put on low precipitation heads, so MP rotators. These put out, instead of 1.5 to 2 inches of water in an hour's time, they will actually put in 0.37 to 0.5 in an hour. So you run the sprinklers longer because you got to get the water out. But the best thing is that it allows for infiltration to occur. You're not putting it all out in one period. It just does it out very, very slowly. And then you can easily adjust them in various different types of patterns. Okay, so that's those. Rain barrels, all different types available. This is just a quick calculation. 1 inch of rain on a 500 square foot roof surface will yield 300 gallons of water. So average Sacramento rainfall is approximately 20 inches. That would give you about 6,000 gallons of water that's free falling from the sky. You might be able to use it all at once, or you might have to use it over time, but eventually what we did is we basically irrigate any potted plants, or if there's a vegetable garden or something in a container, that's what we use it for. Last landscape is very similar to the middle landscape, except now we've gone to almost all natives. There's about 95% native plants in that landscape. There is no turfgrass anymore. It's been replaced with sedge grass. Okay? We thought we would save quite a bit of water using the sedge grass, but sedge grass is sedge that lives in a marsh. So if you don't irrigate it in the hot summer, it starts to go dormant, starts to look bad. So you almost have to irrigate it just like it was tall fescue. It looks its best doing that. Same things as gravel pit. We had rain barrels we didn't put in. We actually put in these stormwater infiltration devices buried in the ground. Runoff comes off the roof, takes it out to this tub that's in the ground, and there's holes punched in the side, similar to the gravel pit, allows the water to infiltrate back out. So all those things that I'm talking about, where we're talking about infiltration, are good when you don't have heavy soils or you don't have really shallow groundwater. If you have those two things, and then you're on top of that using a lot of fertilizer and a lot of pesticides, you're going to have some contamination issues that you're dealing with. So you have to look at both of those. We used all drip and low volume spray. Smart timer, so the ET clock, that's looking at the weather. We had a little weather station in the backyard taking care of that. And then we did extensive hydrozone. This had actually 24 hydrozones. Okay. So there's that landscape. Shows in the back, there's carrots in the back. We had interlocking pavers in the driveway. There's the clock with the weather station, drip. Shows you the carrots in the front. Lots of salvias. Okay, those are mostly just showing you different plant material. There's a picture of the collection vault for that particular landscape, so all the runoff goes to that collection vault. And then we can actually analyze that surface runoff as well. We just collect a sample at the output there and analyze it for whatever we're interested in. Okay, so let's go into, here's that infiltration device I was telling you. It's called a flow well. It's made by NDS. They have all kinds of products out there now. I'm seeing them more and more. Actually, I've seen these at Home Depot now. You can stack them on top of each other or side by side if you need to increase the volume, because they're about, I think they're probably about 50 gallons around there. That's how much water. If the soil is really sandy, you can punch more holes. They're actually pre-scored for you. You can punch more holes in it. If it's really heavy soil, you just punch fewer holes, and it holds the water longer and lets less water out as fast. Okay, one more thing I wanted to question.
It pumps the rainwater?
No, it's just basically gravity. Comes off the roof.
Right.
Pipe, 4-inch pipe takes it out to that container, and it just holds it.
Oh.
And so there's holes punched in the side. It's basically so you don't have this big marshy mess of wet soil all the time, and it just allows the water to very slowly move out that container back into the surrounding soil.
Oh, yeah.
Yeah. So I wanted to show this because there's often this idea that native landscapes, not a lot of green waste. Well, a lot of green waste is generated if the homeowner wants a native landscape, but they also want it to continue to look pretty good, and they don't want these salvias getting 8, 9, 10 feet tall and then falling down, and you do have to keep trimming them on a regular basis. So I have gardeners that came to me quite a bit, professional gardeners, like, well, what are we going to do if everybody gets rid of their lawn? We make all our money on mowing and blowing and going on to the next house. What are we going to do? And I said, believe me, there's plenty of things you can still do, because a lot of these plants, to look good all year round, they're going to need some maintenance. And so they just need some training on that. But this just shows you in this landscape, this is all Salvia clevelandii, some sycamore. We do this twice a year in this landscape to keep them right around 3, 4, 5 feet tall. Otherwise they get taller than I am, and then they end up falling apart in the middle, and then you have to take the plants out. Okay, here's just some data for you from the landscapes. There's the system, there's the curb core. The water goes into here, pumped out. We have a data logger inside each house. It tells me how much water is being used. So here's from February 07 to April 08. So the typical landscape. Remember we had on really bad irrigation every day, no matter what. This also includes any rain events that occurred. On running total, we had 879 gallons of water used today on that landscape. Okay. The daily average runoff from that landscape was 21 gallons. So if you can kind of imagine how much water that is running off a single home. Now remember, if you multiply this out, the size of the development is a lot of water. The type 1 and type 2, 287 for the middle one, 372 for the native landscape. This one always gets people all excited because the native one is using more water. But when I installed this native landscape in January of 07, I installed it when you should install native landscapes in the winter. We only got 2.5 inches of rain in Orange County that year. So I had to add a lot of supplemental irrigation. So that's why this has gone down quite a bit over time. But you can see our mitigation strategies, just the design, our runoff now is down to 6 to 8. Most of that runoff that you see right there is from rain events falling on the sidewalk and the apron of the driveway, because we don't have any really way to catch anything in that. We didn't design anything. Here's the through September 2010. You can see how we've even, after, because this includes establishment, we've even decreased it more. And this is after we've made those adjustments that I mentioned earlier, just fixing sprinklers, using the watering index now. It really reduces things down. Now, more rainfall though. We had some more rainfall in the year, so we did drive things up a little bit. I think a lot of this difference here is the driveway, because we're using interlocking pavers here, which do allow some infiltration to occur, but not as much as our slot drains do in this landscape. Okay, one last thing that we did is we wanted to find out what happens when we do some pesticide applications to these 3 landscapes, and then let's say the homeowner themselves did the applications or they had a professional do it, and then they decided that they needed to hose down their driveway or their walkways or whatever. People do this all the time. I see people in my neighborhood all the time right before some kind of event or whatever, or they spill something in the driveway, they'll go ahead and wash down the whole driveway on, keep everything nice and clean. And so we think that's one of the ways that a lot of the pollutants, especially pesticides, are moving. So we did this pre-treatment wash of all our driveways. We did an analysis of what was in that water to make sure we didn't have any pesticide already in that water. Then we came through with a professional that did a perimeter treatment for ant control. They used a chemical called Perforated. They went around the structure, just the structure, and did a perimeter spray, which is what they would do at a typical homeowner's house. Then I went down like a bad homeowner and I bought a big jug of bifenthrin, which is for just a general broad spectrum for any kind of insect you would have in your lawn. It basically kills everything. Hose-end sprayer that I could buy. You hook it to the end of the hose, and as soon as you turn on the water, it starts dripping out all over you. And basically did a treatment on the lawns in all 3 landscapes, or the front of all 3 landscapes. Okay, and then after that, we came through and we hosed the driveways off on predetermined times. So 24 hours later, 7 days later, etc. So I just want to show you that data real quick. There's just cleaning the landscapes, hosing it down. This is what you get. This is the typical landscape 24 hours later. So this is parts per trillion, which is a very, very tiny amount of, when you're measuring, but that's extremely toxic, that level, 444 parts per trillion. Okay, so if that water were to get into a creek or stream and it was monitored for toxicity issues, it would cause the death of quite a few organisms. The other 2 landscapes you can see. Second, I think this issue has to do with when I'm hosing down the driveway, I'm actually missing a lot of the slot drain because of the high pressure. I'm throwing and splattering things over the slot drain, so it's not this nice even flow falling into the slot drain. So I think that's why it was a little bit higher there. So there's Perforated, and here's my spray. So I know this is kind of messy here, but what you should see, notice here is that this is the typical 24 hours. So even though these are high, this one is actually, right down here, 125,367 nanograms. Okay? These are 32,000. So it's considerably less, even though the bars are really high. I just wanted to be able to show you. So over time, what happens, eventually you don't have any material. But what also happens is if you're doing this kind of activity and washing things off on a regular basis, it's not going to, your pesticide's not going to work anymore. You're basically washing it off, especially perimeter sprays. So what people have to do is call the professional person to come back. They come every month or every other month because it doesn't last. You basically get rid of you can apply the pesticide and then you're basically just washing it off. Okay? So there's a few things to think about. I already mentioned this several times. Infiltration can actually do more harm than good. So you need to know what system you're working in. What's the groundwater, what's the expansive soils, all those kind of things. Or maintenance of water retention design things. So anything where you're maintaining or design something like a swale or any of those types of things, and you're going to have standing water, they've got to be designed properly where you're not having standing water for longer than about 72 hours, especially when it's warm, because you're going to have mosquitoes. Okay, so even rain barrels, where there's concern that if people start all collecting rainwater, that they're not going to maintain them right. They're going to keep them uncovered, and then we're going to have a bunch of mosquito breeding grounds. So people need to keep those things in mind. I think probably the most important thing is this plant selection and the irrigation. Okay, I think they're really the key things that need to be done properly in the urban landscapes, especially for residential homes. Even though each residential home is unique in some sense, when you scale that up over to the large areas, and I think Lauren told me a little bit ago that he showed you some graphs of the low density and very low density development across just Sacramento County and how much area that actually covers. So when you start thinking on a much larger scale, each home contributing a little bit to that the pollution adds up. Okay, so a lot of the things that we originally tried came out of these two books, and you have a copy of the River Friendly. When you flip through there, you'll see some of their ideas, and a lot of them 5 or 6 years ago is where I got those ideas, because that was what was being pushed. But when you talk to a lot of these people, it hadn't really been tried to see, do they work? And we're still kind of doing our own studies. There's questions about how long will that gravel pit, will it get full of sediment and no longer work? Is it 5 years that it'll last? Is it 10 years? Sooner or later, you're going to have to go in there and probably remove the gravel and put new gravel in. So those are the kind of things that we're still looking at. And we want to be able to tell people, yeah, if you're going to design this into a landscape, then the maintenance on this is going to be, the longevity, it's going to be this X amount of time. There's also some really good books by Brad Lancaster, if you're interested in designing things for rainwater harvesting. He just doesn't talk about containers, he talks about just the overall design on how you shape the landscape itself. So there's some really neat ideas in there. All right, any questions? Anything else you want to get?
Any questions for Darren?
I have a question.
Yeah.
With the buffalo grass, that aesthetically, how did that compare to the fescue?
So far, so I've had it in for a year, so I've gone through one winter. I mean, the issue is always, dormancy issue, what people like. People like it when it's green, but the question is, will they like it in the next coming months? The first year we put it in, which I've been told, the first year you put it in, it doesn't normally go dormant because it's so actively growing. So I'm going to be curious to see what happens this year. In the back, I haven't mowed it. I let it get the 5 to 6 inches tall. And my plan this year is if we have some pretty cold weather, I was thinking of overseeding with some wildflowers or something and kind of showing it as a meadow. And then I'm thinking once it warms up again, and those start to die out, the wildflowers, the buffalo grass will come back in. Depends on where you're located. Closer to the coast, less chance that it's going to go green. Further inland, yeah, you're going to have more issue. But people like it. It's very soft. They don't mind walking. I'm amazed when you talk about turf grasses. People like to take their shoes off. And I have these field day things, and people do it all the time. I'm thinking, it's not something I normally do, but they want to see how it feels to walk on and all that kind of stuff. So they seem to like it a lot.
It's been tested in Visalia for 3 years now in both commercial, industrial, and residential settings. It's doing really well. It has a dormancy period of about 9 to 12 weeks. But
and it's not like Bermuda where it just completely goes brown usually. It's kind of an off-color, limey green color.
Right. Okay. It doesn't look dead.
Yeah, it doesn't look dead. Unlike some of the original buffalo grass cultivars that were brought in from Nebraska and those kind of places, those didn't do that well there. They basically just, people kind of got turned off by them. So when you say buffalo grass now, they often think of those older ones. So, but this one was specifically bred for California.
Anything else? So if you came in later and you didn't get one of these sprinkler keys, you'd like to just come up.
Yes, so if you don't have sprinklers to adjust, give it to your parents or give it to a neighbor that's got bad problems with irrigation running off.
Thank you.